Hello and welcome to Advancing Women in Tech, AWIT's Real World Engineering Management Specialization. My name is Nancy Wang. I'm the General Manager of Data Protection Services and Governance Services at Amazon Web Services, or AWS for short, as well as the founder and CEO of Advancing Women in Tech. Our content is unique because it emphasizes real-world education, meaning that we teach from the same material developed and taught at the most popular and successful tech companies that many of you may have heard of and would someday like to work for. This is AWIT's third Coursera specialization in 3 years, and I'd like to thank AWS and Coursera for their continued support in helping us produce this quality content for you all. We also feature instructors who are full-time executives at top tech companies. Our instructors are the same ones who make the hiring as well as promotion decisions for engineering managers. During this specialization, our distinguished instructors for this specialization will include not only myself, but some of the leading tech executives from companies such as Stripe, such as Google, such as AWS, Microsoft, and so many more. In this specialization, we look at how some of the most successful technology companies in the world, including Amazon, Google, and Microsoft, train and evaluate their engineering managers and technical program managers. We focus on these engineering organizations because billions of people around the world rely on their products billions of times each and every day. And of course, these companies are tech-driven, which means that engineering managers and technical program managers are in decision-making roles, and they get to drive the future of these companies. These companies have achieved success, scale, talent, technology, and data to become leaders in the discipline of managing engineers. We've structured this specialization to address common questions that these companies will ask engineering manager candidates during interviews. So the following are 10 common questions that I ask engineering managers who want to work for me that form the outline for how we created this course. 1. Who was your best hire and why? 2. How did you help her perform and grow? 3. Who was your worst hire and why? 4. How do you handle poor performers? 5. Tell me about a time you managed a conflict. 6. Tell me about your biggest mistake and what you learned. 7. What are your management processes and mechanisms? 8. How do you ensure your deliverables are of the right quality? 9. What metrics would you track? And 10, for a fun exercise, let's design YouTube together. Throughout the lectures in this specialization, we'll often refer to the engineering manager as you. We do this to put you in the engineering manager's seat, help you think through challenges as an engineering manager might. No matter your background or career objectives, you're welcome to take this specialization to learn about how top technology companies train their managers. Perhaps you are thinking about becoming a manager in the future. That's a great career goal, and we are all here to support you. This specialization will help you identify your strengths and weaknesses as a manager, and also provide you the tools to address your weaknesses and grow quickly. So maybe you just got asked to lead your first project or mentor your first intern. Congratulations! This specialization will give you all the tools you need to work effectively with your team so that you can spend more of your time doing the work rather on managerial overhead. Perhaps you want to remain an individual contributor, but you also want to learn managerial skills to work better with your manager or other members of your team. This is a brilliant investment of your time. As you know, when you grow in seniority, you'll spend more and more of your time advising managers and mentoring junior team members, even if you are not interested in becoming a manager yourself. Taking the time to learn managerial skills can help individual contributors, if you choose that to be your career path, accelerate that career path. Finally, maybe you've already become a manager and you're using this as an opportunity to look for new ideas, frameworks, in which case you're really welcome. I hope that the content you find here inspires you to create a better environment for the teams that you lead. By the end of this module, you will understand the expectations that elite software engineering organizations like Amazon, Google, and Microsoft have for their managers. 2, explain the relationships between engineering managers and other managers in an engineering-driven organization, such as technical program managers, product managers, and general managers. And 4, articulate the difference in responsibilities, career ladders, and compensation between an individual contributor and a manager. And lastly, identify the business value that good managers bring to these organizations. Are you excited? Well, how about let's begin with a simple question. What is management? Management is the responsibility and accountability that arises from running and transforming a business. Your employees depend on you to make good decisions for livelihood, and your customers depend on your product decisions to accomplish their goals. Question: can you manage a business without having direct reports? Yes, you can. We'll see how briefly. A subtype of management is people management. People management involves creating and maintaining one high-functioning team of individual contributors. Engineering managers are usually people managers. A further subtype of people management is the manager of managers. A manager of managers creates and maintains multiple high-functioning teams that work well together. The opposite of a manager of managers is a line manager. The term line manager is an abbreviation of the term front line manager. A line manager has direct reports who are individual contributors, and for many of us, being a line manager is a step to becoming a manager of managers. The final concept we'll discuss is a team. A team consists of a manager and all of their direct reports. Managers are accountable and responsible for the performance of their team. Now, let's better understand what an engineering manager does by explaining how they work with other managers. Before we move on, I want to share a couple notes from the beta run of this course. First, we found that some Coursera learners didn't get much from this course because they were unable to relate to what a manager does. These learners either had no work experience or had only worked as individual contributors. An individual contributor is someone who is responsible for doing work that a manager assigns to them, but does not actually manage others. During our beta, we found that this cohort of learners had difficulty understanding the rationale behind a number of managerial skills. For example, they could not understand why managers need to protect the team members most likely to leave that team. They felt like learning a basic managerial skill, such as noticing pre-quitting behavior, would cause them to become a gossip, and that this would be negative for them and their workplace. These learners could not relate to the manager's responsibility of shielding the remaining team members from having to pick up all the responsibilities of the person leaving. Nor could they understand the manager's responsibility to start the hiring process early and have a replacement early and train to replace the person leaving to prevent strain on the rest of the team. So, if you have no management experience coming into this course, I would encourage you for the duration of this course to stop thinking like a student or an individual contributor, but rather instead start thinking like a manager and a boss. Think like you are responsible and accountable not only for your own personal success, but for the success and happiness of a team of people beyond yourself. Second, some members of our beta told me that they wanted to read my content as I covered it because reading helped them learn. So if you want to do something like this, you can turn on subtitles by clicking or tapping the option to show transcripts in your Coursera video player to read along. Now, I'd like to hear from you. Please take 2 to 3 minutes to let me know about your career goals and what you're hoping to learn from this course. Lesson: what other managers expect from their engineering manager. In this lesson, you will learn what other managers expect from their engineering manager. If you've ever wondered who builds an application that people use billions of times a day, here's a highly simplified organization chart, or abbreviated org chart. An org chart like this is an important tool for managers because it specifies the roles and reporting relationships and is a source of truth for who is responsible for managing who. This particular org chart is fictitious. It does not represent a real business. At the top of this org chart is the general manager. This is the executive who is responsible for the overall direction of a particular business, which could consist of one or many products. For example, I'm the general manager for AWS Data Protection and Governance Services, where I lead all aspects of AWS data protection and governance, including engineering functions, product management, user experience and design, strategy, marketing and positioning, as well as sales and business development. The general manager's role is to advocate for the business. Good general managers cultivate relationships with other executives within their organization to gain commitments and resources. They also attract and negotiate strategic partnerships with customers, other companies, and even entire industries. They might even make appearances in industry events and the press. Their activities shape the public's understanding and discussion of their industry. I want to point out that the general manager role is very common within Amazon, but it may also not be super common for other tech companies. Amazon likes the concept of a general manager because that individual represents a single-threaded owner of a business. A single-threaded owner is an executive who is 100% responsible and accountable for the performance of their business. And although it's not their most important goal, the general manager is knowledgeable enough to personally take charge of any part of the business. For example, at one point when I was first becoming a general manager, I managed 29 engineering direct reports. Now, that's a lot. This made me a general manager and an engineering manager at the same time. So note that general manager may only exist at certain tech companies like Amazon. There is currently not an equivalent to the general manager role at companies like Google or Microsoft. At those two companies, the head of engineering reports to a higher-ranking engineering manager, and the head of product reports to a higher-ranking product manager, for example, a director of product. Under this shared leadership structure, the responsibility and accountability for the performance of a business is shared across multiple functional leaders and diffused across people who are in different functional roles, such as product, design, engineering, sales, so on and so forth. Two of the key people who report into the general manager are the head of engineering and the head of product. Notice that while neither word has the word manager in its name, both roles are people managers because both have other people reporting to them in this org chart. Also notice that in this org chart, the head of engineering is a manager of managers, while the head of product is not. This is because the head of engineering has 3 engineering manager reports, each of whom manage other engineers, whereas the head of product has 3 product manager reports, but none of these reports also manage other people. Let's take a look at the engineering slide first. So what does a head of engineering expect from an engineering manager? Those expectations can be summarized as 2 interrelated goals. 1, grow your engineering team, and 2, deliver on your commitments. Growing your engineering team can mean many different things, but at minimum, it means that your team is growing in both the number of engineers and the capabilities of each individual engineer. To manage the number of engineers, your head of engineering might give you a growth target, such as you need to hire 5 more engineers by June. In this case, you must represent your team to the public, convince qualified engineers to apply, shepherd them through your organization's interview loop, and select the best ones to be on your team. In this example, not only do you hire 5 more engineers by June, but you might also need to hire more engineers to account for attrition. What is attrition? Attrition is a natural process of losing engineering talent from your team through any number of factors, including an engineer who decided to retire or pursue a role at a different company. In order to make sure that your team continues to grow, you can hire more people to backfill for your attrition. You can also minimize attrition by becoming a manager that your engineers would prefer to follow, rather than deciding to jump to an unknown situation at a different company. We'll talk more about how to become a manager who is worthy of a following of engineers when you have engineers just reaching out and asking to work on your team throughout this specialization. Just how much you need to grow your engineering team depends each year on so many different factors. In my experience, I've seen very fast engineering teams grow because of a large amount of customer demand, or sometimes because they're launching a new business or a new product line that is going to generate much more revenue for the company. In contrast, I've also seen slower growing engineering organizations because perhaps there isn't as much customer demand, or because the engineering team itself might be in charge of maintaining a more mature product, who is potentially launching future releases or versions of the initial product, but nothing net new is being launched. So a lot of different situational factors can play into how fast your engineering team might be growing, and again, translating to, if you were an engineering manager, how quickly you need to hire for new engineers. Finally, growing your team also means giving existing team members opportunities to grow their own careers. This might involve advocating for your engineers to receive promotions, giving them roles such as tech lead, and staffing them on projects that stretch their abilities. As you grow your team numerically and it becomes more difficult for you to manage it alone, you will be expected to mentor your direct reports to become managers themselves and prepare them to spin off their own teams. Successfully doing this demonstrates your ability to cultivate and to work across many engineering teams, and makes the case that you might be ready for a promotion to be the next head of engineering. The other expectation the head of engineering expects of you, the engineering manager, is to be responsible and accountable for fulfilling your commitments. Later in this course, we'll look at how you create commitments by setting goals and how you track your progress for fulfilling your commitments. For now, suppose that you're an engineering manager who has agreed to 2 fictional goals. 1, Launch feature A on June 30th and launch feature B on September 30th. And 2, keep high severity tickets below 100 during the calendar year. Now, if you're not sure what those terms mean right now, well, don't worry. We'll teach you and we'll explain in more detail later in this specialization. What you need to know now is that the head of engineering expects you to accomplish these goals and that you will keep her informed on your team's progress throughout the year. Throughout the year, you will monitor your progress towards these goals. And if your team gets mired in conflicts, it's also up to you to resolve these conflicts. Otherwise, if your team encounters external blockers, it's up to you to remove those blockers. We'll talk more about goal setting and specialization. Now, let's take a look at how engineering managers work with product managers. Reporting into the head of product are a team of product managers. If you want to learn about product management, check out our first 2 specializations, the Real-World Product Management Specialization and the Real-World Cloud PM Specialization. Both are available exclusively on Coursera for the skills that big tech companies expect of their best product managers. I'll provide links at the end of this lesson. To greatly simplify, the product manager's role is to advocate for the customer. They spend a large percentage of their time in meetings with customers or responding to customer questions and issues. They also maintain the product backlog, which is a list of product feature requests made by customers. The product managers are constantly reprioritizing the number and the order of the items in the backlog based on a number of factors, an important one being shifts in customer demand. Notice that although individual product managers in this org chart are not people managers, their title has the word management because their decisions affect how the business is run. This is because decisions guide what everyone else works on. When an engineering team becomes available, a product manager pulls a product feature request from the top of the product backlog and engages the available engineering team. The product manager also uses her extensive knowledge of the customer and business need to scope the feature request in a product requirements document that defines what the engineering team should build now, what it can build during a later release, and what it should not be built. Remember that the product manager is the advocate for the customer, meaning that a skilled product manager can make very convincing arguments that a large number of feature requests are essential for customers and need to be built right now or as soon as possible. This type of advocacy is very valuable because it gives you the data to communicate purpose and urgency to your team. However, it is your role as the engineering manager to seriously consider whether your engineers are capable of developing as many features as the product manager wants on the timeline they want, and if not, to push back. This is the role of the engineering manager, to be the advocate for the engineers. The engineering manager advocates for the engineers by negotiating with the product manager over how to build the feature and when it will be ready for delivery. To do this, you will clarify and de-risk the scope, assign engineers with the right skill sets and interests to the project, and estimate a reasonable schedule that protects engineers from burnout. These considerations are called the triple constraints of product management. The triple constraints in traditional management are scope, cost, and time. Scope is a decision that starts with the product manager's product requirements document. The engineering manager's team drafts and reviews a corresponding design document that explains what they intend to build. Sometimes, the engineering team will discover that the original scope is technically infeasible or otherwise flawed. In that case, the engineering manager and product manager must negotiate over how to move ahead. An example of this might be, let's say your big boss, right, vice president at a top tech company like Google, for example, comes and tells you that, hey, this project that was originally slated for Q1 of next year, which means that you have more than 20 or more than 12 months to complete, is now due Q3 of this calendar year, cutting your time estimate by roughly half. Now, what do you decide to do? If you were in the product manager's shoes, you would think about, if given a constrained timeline, what are the most critical product requirements, right? Or what goes into your MLP, which is the concept we cover in our real world product management specialization. Now, if you were on the engineering manager side, you might be wondering, well, I'm responsible for the livelihood and happiness of these engineers who have been committed to delivering this project. And now that this timeline has been cut in half, I don't necessarily want to double their workload. Now, that wouldn't be fair to the engineers, but how about I negotiate a sufficient scope with the product managers who are advocating for the customer need to make sure that whatever we build will be able to be completed on time, and thus making executive leadership happy. In fact, that's a very common conversation that happens between my engineering team and my product teams on nearly a daily basis. Because look, customer demands change, just like leadership requests might change. And so in this day and world of agile software development, being agile in terms of how you assign resources or how you might define the MLP and priorities and product requirements need to come together to create a good situation. Cost traditionally meant the compensation of workers plus the cost of materials, like data center leases and server purchases. However, since Amazon invented cloud computing in the 2000s, most software engineering organizations pay much lower costs to use cloud computing. This has had the effect of making costs for materials negligible. So unless your team is in charge of managing a data center and buying the servers therein, your only major cost constraint is that of engineer compensation. However, it is awkward to invest in internal projects based on using engineering compensation. It might also result in strange outcomes, such as staffing less well-paid engineering teams on more complex projects. So big tech companies don't necessarily use the cost constraint. Rather, they combine the constraints of cost and time into a single constraint called engineering months, as in, I believe that this feature will take 35 engineer months to develop and ship. Another example, with 7 engineers on my team, I think we can complete this in 5 calendar months. Another way to understand the engineering manager's role is to think of them as a force multiplier for their team. Effective managers constantly prioritize how to spend 1 hour of their time to create an additional 10 hours or 100 hours of engineering time for their team. That is the definition of force multiplication, inputting 1 hour of effort to free up 10, 100, 1,000, or even 10,000 hours. For example, a manager who spends 1 hour performing code reviews might only have freed up 1 hour of engineering time for her team. In contrast, an effective manager, although she might also excel at code reviews, is more likely to spend that 1 hour on recruiting activities, such as convincing a new engineer to join their team. This 1 hour investment produces over 2,000 additional engineer hours per year for that team. Now, let's discuss the difference between 2 words I've used repeatedly and intentionally: responsibility and accountability. Each manager is expected to frequently delegate responsibility and never delegate accountability. Responsibility means that someone must complete the task at a certain time within certain parameters. Managers with teams frequently delegate responsibility. This is why they have teams. As a general manager, no one expects me to write the code for all of my features by myself. Likewise, no one expects engineering managers to do all the work they're responsible for personally. For example, if a product manager requests a technical design for their feature, you, as the engineering manager, can delegate that responsibility to any of the engineers on your team to complete. However, Everyone expects the engineering manager to never delegate accountability. Accountability is ownership of the outcome. It means you perform the appropriate number of audits and check-ins to verify that work you have delegated to others is being done correctly and on time. It also means that you take the blame and own the next steps if those you are delegated to are unable to achieve the desired outcome. For example, the other managers and I would expect you to be accountable for that technical design, even if you decide to delegate it to someone on your team. If your engineer's design turns out to be infeasible, we then would expect that you take the accountability to detect it and remediate it as soon as possible, and generally by delegating responsibility again without impacting the triple constraints. This simplified org structure can suffice for new or simple businesses, but in complex projects in big tech companies, engineering teams can take dependencies on other engineering teams. For example, suppose that the third engineering team's feature takes a dependency on the second engineering team, meaning that the second engineering team must finish their work before the third engineering team can finish. Now, suppose that the second takes 3 dependencies across engineering teams elsewhere in the organization. Assuming any one of these external dependencies get delayed, they will cause cascading delays into project 2 and 3. It can also be difficult for engineering managers to monitor these webs of dependencies because they are so focused on their own team's performance and commitments. That's why this specialization features another management role at big tech companies, that of the Technical Program Manager, abbreviated TPM. The Technical Program Manager applies the skills of an engineering manager at a lower resolution across multiple engineering teams. They regularly report on the status of all related projects and have the responsibility to be the first to call out if there's a risk in one that could affect delivery in others. All the content engineering management also applies to technical program management. And towards the end of the specialization, we have a module that is dedicated to technical program management. Now that we've described what other managers expect of engineering managers, let's zoom into an engineering team and explore the differences between engineers and their managers. How engineering managers compare to engineers. In this lesson, you will learn how engineering managers compare to engineers in terms of role, career ladder, and salary. This is what an engineering 2-pizza team might look like at Amazon. The 2-pizza team is a concept that originated from Amazon. It states that each team should be of a size that it can be fed with 2 pizzas, which might be around 7 people. Amazon's logic is that larger teams spend more time coordinating and communicating, which reduces the time they have to deliver on their commitments. When a team grows too big at Amazon, we split it into a separate team with another manager. For example, back when I managed 29 engineers, one of my responsibilities was to either transition some of them to engineering managers or to hire new engineering managers. I did both. Note that organizations have different expectations for team size per manager. For example, when I was at Google, 30 engineers reporting to the same manager was pretty common. In this sample 2-pizza team, there's 1 senior engineer, 3 engineers, and 3 junior engineers. We'll use these to illustrate the career ladder for individual contributor engineers at Amazon. The corresponding job ladders at Google and Microsoft are similar, with the biggest difference being that they have more levels in between their junior and senior levels. Note that the 2-pizza team concept might not be recognized at other engineering companies. For example, at Google, it is acceptable for an engineering manager to have upwards of 30 direct reports. Now, let's compare the 2 parallel ladders for managers and individual contributors. Why are there 2 parallel career tracks? Because transitioning to a manager is not a promotion. It is a total career change. The transition to manager is less formal than if an engineer decided to go to law school and become a lawyer, or to med school to become a doctor. but the concept of it being a career change is still the same. Let's explore this concept using the parallel career ladders. First, we'll take a look at the career ladder for individual contributors. Then, we'll contrast that with the levels for managers. New engineers who have completed an internship and graduated from university are often hired as L4, which means level 4 with the role of an SDE 1. SDE stands for Software Development Engineer. An SDE 1 generally works in the following manner. They receive clearly scoped, well-defined problems from a senior engineer. Then they go and develop their own solution. Their solution might benefit from more senior engineers' review and refinement. Once an L4 SDE 1 demonstrates that they perform on the level of an L5 SDE 2, they become eligible for promotion to that level. An L5 SDE 2 works more autonomously and on problems of larger scope and more ambiguity. Although they are still individual contributors, they're expected to help advise the manager on their team, as well as delegate more manageable problems to other engineers and mentor their development. Once an L5 SDE 2 demonstrates that they perform on the level of an L6 SDE 3, they become eligible for promotion to that level. An L6 SDE 3 solves complex and difficult problems involving an architecture that affect many teams. The L6 also advises managers and delegates to other engineers. Independent from these roles is the designation of a tech lead. The tech lead is the team member who is responsible and accountable for all technical decisions that are made by that team. This is often the role of the L6 SDE 3, although it might also be served by the manager if she is highly knowledgeable about the technology or an engineer of another rank. The next level is the L7 Principal SDE. The Principal SDE actively shapes the discussion in the broader technical community. Engineers across all of Amazon view Principal SDEs as technical authorities for their areas of expertise. Individual contributor engineers can also rise to even higher levels, such as L8 Senior Principal SDE, which is on par with most directors, and the L10 Distinguished Engineer, which is again at par with other vice presidents. One example of a Distinguished Engineer, L10, at Amazon Web Services is James Gosling, who founded the Java programming language. Java, as many of you know, is one of the most popular programming languages in the world. Now, let's compare the individual contributor career track to the parallel manager career track. The first engineering management role is that of the L5 SDM2. SDM stands for Software Development Manager. The L5 SDM2 is responsible for the delivery of a two-pizza team that generally consists of L5 and L4 SDMs, meaning that L5 SDM2 generally do not get to manage L6 engineers. The L5 SDM2 is responsible for delivering smaller technical deliverables on time. Once an L5 SDM2 demonstrates that they perform on the level of an L6 SDM3, they are eligible for promotion to that level. The L6 SDM3 also manages a two-pizza team, but this team often includes one or more L6's engineers in addition to L5s and L4s. The L6 SDM3 is responsible for delivering larger, more strategic technical deliverables over time. In my experience, this is the most common transition into management, and it's a good one. As an L6 individual contributor, you're already a senior engineer with substantial technical experience to manage engineers of equal or greater technical depth. The L7 Senior SDM is often a manager of managers and can manage engineering, including L7 Principal SDEs. They are responsible for delivering the business vision by orchestrating all of the many two-pizza teams they manage and by obtaining buy-in from other engineering leaders that they do not manage. Like with individual contributor career tracks, there can be higher levels in addition to the L7 Senior SDM, such as the L8 Director of Engineering, which can manage multiple L7 senior SDMs and managers who report to those senior SDMs, as well as the L10 Vice President of Engineering, at which point that individual often leads product, engineering teams, and multiple general managers. So when I say that these are two parallel career tracks, I mean that in large tech companies like Amazon, you're free to switch from one track to the other at any time. If your organization allows it, you can even negotiate a trial period to try a management role for several months and decide if you like it. However, these parallel tracks also mean that experience and time in one track does not count for promotion into the other. For example, if you spend 4 years as an L6 engineer, then transition to an L6 manager, you generally cannot use any of the previous 4 years to argue for a promotion to L7 manager. I'll explain why in a moment. But first, let's talk about total compensation. In the popular imagination, managers make more than individual contributors, but this is not necessarily true at large tech companies. For example, let's take a look at Microsoft salaries that people reported to the website levels.fyi. Levels.fyi aggregates total compensation paid to people who work at large tech companies. For the people I mentor, I highly recommend that they review levels.fyi or a similar resource to make sure that their compensation is fair market value. According to the levels.fyi data, level 63 engineers and managers make roughly the same average compensation at around $230,000 a year. At the next level, they continue to make roughly the same average compensation at approximately $260,000 a year. At level 65, however, engineers make an average of $315,000 a year, whereas managers make less, an average of $300,000 a year. At level 66, managers continue to make less than engineers, with engineers making an average of $370,000 a year, more than the manager's average of $360,000 a year. But at level 67, the managers finally make more than engineers on average, but not by much. Engineers make on average $500,000, whereas managers average $550,000 a year. You can see a similar pattern for other large tech companies. On average, managers do not make much more than individual contributor engineers. Sometimes, on average, managers make less. These averages are also generally true for both Google and Amazon. There are two important takeaways. In big tech companies, managers do not necessarily make more than the people they manage, and your individual compensation follows how well you do in your role, not whether you decide to become a manager. Now let's return to the previous question. Why can't you count 4 years of experience as an L6 engineer towards your promotion to an L7 manager? Well, because the skill sets are very different. The first chart shows the time expectations for IC engineers. The biggest portion of this chart, the blue section, shows that ICs spend most of their time on core IC work, such as writing and reviewing code. The second chart shows the time expectations for engineering managers. That blue section for core IC work, which was so large for the IC engineer, has shrunk to the least amount of time, at 5%. Instead, the manager's largest time commitment is 2 regular meetings. Examples of regular meetings can involve regular one-on-ones with individual ICs, daily stand-up meetings with your team. For example, if you have 7 direct reports that you meet weekly for 1-hour one-on-ones, you can spend what amounts to an entire workday each week in one-on-one meetings working with your direct reports during these one-on-ones. The next largest time commitment, the green 20%, which takes up a cumulative 70% of your time, is team growth. This involves hiring people to grow your team. These are also meetings in the sense that you're often meeting people outside of your team with the objective of bringing them onto your team. The next largest time commitment, the yellow 15%, which takes up a cumulative 85% of your time, is planning. Planning involves setting your goals for the team based on your estimation of how much work they can reasonably perform. as well as redeploying your team to handle emergent issues and adjusting your plans as a result. The final time commitment is the orange 10% relationship building, which takes up a cumulative 95%. Developing strong relationships with your reports helps you motivate them to perform at a high level. In that same vein, developing strong relationships with others outside of your team, but within your organization, gives you opportunities to later call in favors throughout the organization that might help advance your team. However, in order to do that, you first have to nurture these relationships over time. In conclusion, these charts illustrate the fact that engineers and managers bring two completely different skill sets to solve two completely different issues. At the most fundamental level, I see engineers solve technical issues by writing code. Engineering managers solve people issues by meeting with people. In this lesson, you will learn what engineers expect from their engineering manager. David Garwin, endowed professor at Harvard Business School, observed that at Google, quote, most engineers want to spend their time designing and debugging, not communicating with bosses or supervising other workers' progress. In their hearts, they believe that management is more destructive than beneficial. Management distracts them from real work and tangible accomplishments. In order to make Google a better place to work, co-founders Larry Page and Sergey Brin listened to their engineers. In 2002, they removed all of their engineering managers. After this reorganization, every engineer at Google reported into Larry Page. What do you think happened next? Google engineers inundated Larry Page with expense reporting issues, vacation and time off questions, escalations, and interpersonal disputes and conflicts. The change severely degraded Larry Page's ability to lead Google. So, several months later, Google reinstated its engineering managers. In 2002, through this exercise, Larry and Sergey learned engineering managers are not optional. They are required. In an effort that continues to this day, they are applying Google's technology and brainpower to identify how managers can perform better. By 2008, Google had empirically proven that managers who receive high performance and employee satisfaction ratings also retained employees for longer periods of time. This gives rise to the saying, people don't quit companies, they quit managers. Employee satisfaction with a manager was a greater cause of employee retention than seniority, performance, tenure, or even promotions. Furthermore, engineers who rated their manager higher also felt more productive, more innovative, better work-life balance, and more career development than the average Google engineer. By 2017, Google identified two measures of manager performance: manager quality and manager effectiveness. Manager effectiveness is how well other managers perceive the engineering manager, based on top-down performance reviews from the people who manage the managers. In the scatter plot, the dots at the right are the most effective managers. Manager quality is how well engineers think of their managers, based on 360-degree surveys of individual contributors. In the scatter plot, the dots at the top are the highest quality managers. The top right quadrant represents the best managers at Google, those who both deliver results for the company and also command loyalty from their engineers. According to Google, the bottom right quadrant often represents managers who tend to enforce tough deadlines on their teams, making them stretch to reach those goals and burning their engineers out in the process. The top left quadrant often represents managers who try to be their engineers' best friend, but who are less able to make their team deliver on their goals. And finally, the bottom left quadrant represents the less effective managers who lag behind in both quality and effectiveness. Google asks managers who perform below average to improve. If they are unable to improve after several review cycles, in an illustration of how the parallel career ladders work, Google might ask the underperforming manager to transfer back to the individual contributor career ladder. Google also compared the top right and bottom left dots in blue to identify the 8 key behaviors of an effective and quality manager. The 8 key characteristics are: 1 is a good coach, 2 empowers a team and does not micromanage, 3 expresses interest in and concern for team member success and well-being, 4 is productive and results-oriented, 5 is a good communicator, listens and shares information, 6 helps with career development, 7 has a clear vision and strategy for the team, 8 has key technical skills that help him or her advise a team. Most of these characteristics have to do with prioritizing regular one-on-one time spent with your direct reports. For this reason, you should resist any pressure to deprioritize your one-on-one time. During one-on-ones, you collaborate with engineers about how they can accomplish their immediate tasks or career progression, provide coaching, and explain how their tasks are essential to a larger strategy and vision. We cover these skills throughout this specialization. Their characteristics of empowers the team and does not micromanage, and is productive and results-oriented merit more explanation. As one of her force multiplier activities, the engineering manager should make her team self-sufficient. This means that your team can function at the highest levels without your direct intervention. One way to test whether you have achieved this is to take a month-long vacation, return, and observe your team function just as well as if you were present. Steps to reach team self-sufficiency include coaching team members to have ownership and become self-sufficient over answering questions or resolving interpersonal conflicts, creating a structure and procedure for testing software for defects and maintaining software, customizing methodologies such as Scrum and Kanban to create a regular approach that optimizes team productivity, setting up proper logging metrics, alarms, runbooks, and documentation to automate every process from emergency response to new hire onboarding. We'll also discuss how you can automate your team throughout this specialization. Now that Google has defined what a quality manager is, how do you know if you're a quality manager? At large tech companies, your direct reports will routinely fill out anonymous surveys about you. You might also periodically review the anonymous survey results with your entire team at staff meetings. You can share where you're ahead of or behind the company average on the 8 key characteristics and ask for suggestions from your engineers on how to improve. What can you do about this right now? In the next few exercises, you can apply Google's 8 key characteristics to yourself as a current or future engineering manager. Perform a self-assessment about your management capabilities. Keep in mind that no one other than you looks at or stores the answers, so feel free to answer honestly. And answer a quiz to reinforce the concepts that I've introduced. As we wrap up our introduction to management, I want to share one other finding from Google's HR studies. It is that Googlers who take the time every day to write down 2 or 3 things who they're grateful for are consistently happier than their colleagues. And when you're happy, people are naturally drawn to follow you, include you, and offer you more responsibilities. Happiness is a powerful differentiator for your career. 2 suggestions to get you started. First, think about the great managers that you've worked with. Does this content help you understand why they were so great? Well, write them a quick note of your appreciation. Next, did you enjoy this content? If yes, please leave a positive review at the next URL to encourage me, Awit, Coursera, AWS, to create more content like this for you in the future. Thank you so much, and I look forward to seeing you in the next module on hiring your team. Welcome to Course 1, Module 2, Hiring Your Team. In this lesson, we'll cover why hiring is essential for your success. At the start of this specialization, we shared 10 common engineering manager interview questions. The following content helps you answer the questions that imply that you have substantial experience hiring engineers. Those questions are: who was your best hire and why? And who was your worst hire and why? By the end of this module, you will explain why hiring is among the most important management skills and why the majority of engineering managers are unable to meet their hiring targets. Illustrate how you shepherd candidates from your hiring pipelines into your hiring funnel, and explain how you can make confident, data-driven decisions on candidates after spending only a small amount of time with each candidate. As an engineering manager, your ability to hire is essential for your success. Why? As I mentioned during the start of this specialization, engineering managers are responsible and accountable for interrelated goals. 1. Grow your engineering team, and 2. Deliver on your commitments. Your ability to hire has an immediate impact on both. By hiring, you reap a number of benefits, including you directly make progress toward the goal of growing your team. Often, this will be a tangible goal, such as hire 5 engineers in the next 6 months. You also increase the number of engineer months available to deliver on your technical commitments and deliverables. Each new hire gives you an opportunity to increase the diversity of backgrounds and strengths on your team. You demonstrate to a wider organization that you are a high-growth leader. And finally, you negate impacts of attrition on yourself and your team. So remember the definition of attrition from our prior lesson. Attrition is a natural process of losing members of your team through any number of factors, including an engineer deciding to retire or pursue a role at a different company. According to HackerLife, the median software engineer only stays for 1.5 years at small companies and 2.3 years at large companies before they move somewhere new. This chart from HackerLife asserts that the median engineer stays for 3 years at Netflix, 2.6 years at Microsoft, 2.3 years at Google, and 1.3 years at Uber. So if you start managing a full team of engineers in 2 years without hiring, you might be down to a team of half of that original number. What is the impact of your attrition? Well, attrition can frighten you and your team. If a senior engineer leaves, your team might not have enough expertise or direction to deliver on its commitments. If a junior engineer leaves, the senior engineer might get mired in more work, which can cause them to leave. And when a team member's exit impairs the other team's members' ability to do well in their own roles, it can be tempting for other team members to also think about whether they too should leave. Either way, one member of your team leaving can cause more people to leave and create a downward spiral until no one is left on your team and it becomes impossible to deliver on your commitments. How do you prevent these negative effects of attrition? Simple. You hire ahead for future attrition, so when one team member leaves, one or more other team members is already trained and ready to inherit their role. These team members are already familiar with your team's deliverables, systems, and processes and are ready to take over immediately. Although you and your team might miss the engineer who is leaving very much on a personal level, your hiring ahead of attrition avoids business interruptions and protects the psychological health of your team on whole. So, how good are engineering managers at delivering on their hiring goals? One organization that studied hiring across software engineering organizations is Lightspeed Venture Partners. Lightspeed backed more than 400 startups from early to late stage, including Snapchat. Snapchat's founders declined an informal $3 billion purchase offer from Facebook in 2013 and another $30 billion purchase offer from Google in 2016. In 2017, it achieved a value of $33 billion through its initial public offering. According to Lightspeed's survey of over 300 startups, only half of tech startups surveyed by Lightspeed were able to achieve their annual hiring goals. That means maybe half of engineering managers fall short of meeting their commitment to staffing their teams. That also means that one way to distinguish yourself as a great manager is to consistently meet or exceed your hiring goals. So why do managers have such difficulty in meeting their hiring goals? After all, in the previous module, we discussed the relatively high levels of compensation that employers offer for software engineers. The answer is that, at least in the United States, there might be a shortage of qualified software engineers. According to a projection by the U.S. Bureau of Labor Statistics, quote, by 2020, There will be 1.4 million computer science engineer jobs available, and only 400,000 computer science graduates with the skills to apply for those jobs. That means 1 million software engineering roles might go unfulfilled. Meanwhile, software engineers with computer science degrees go through each week getting bombarded with tens or even hundreds of messages from recruiters on LinkedIn and in their personal mail. There's a further complication, which is that a bad hire can severely diminish your team's performance and even cause existing team members to leave. So the pool of talent is not all seemingly qualified engineers, according to LinkedIn profiles, but the smaller pool of qualified engineers who are also knowledgeable, mature, professional, and a culture add for your team. This all means that engineering managers like you will spend a great deal of your time, energy, and intellect on hiring. So do you remember this chart that I shared with you during my lectures? It shows a manager's time commitments. The second largest commitment of a manager's time, the green 20%, is team growth. That means that it's entirely reasonable for hiring activities to take up one full day of your 5-day work week, and very important that you schedule it on a regular basis so hiring becomes a pattern and a habit for you. For example, for me and my managers, we typically schedule about an hour or even sometimes multiple hours a day in order to look through profiles of candidates to build our pipeline and to make sure that existing candidates are moved through the hiring pipeline, through on-sites, through phone interviews in a quick manner. And since you'll spend so much time on hiring activities, it's important to spend your time efficiently. That's how we'll spend our time together. So by the end of this module, you will be able to explain the recruiting funnel and the manager's role at each stage of the funnel. 2, explain the different roles of the manager and recruiter and how to work well with recruiters. And 3, how speaking with qualified engineers and convincing them to join your team. In addition, we'll have a number of activities for you to complete that might lead you to helping your team make its next hire. Lesson 2, recruiting funnels and pipelines. The recruiting funnel is a process of narrowing down a pool of candidates until you're left with the one that you want to hire. When you apply for a job, you're vaguely aware that there's some chance that you'll get the job and some chance that you're not. One popular statistic is that it's 10 times harder to get hired by Google than to gain admission into Harvard. And that's true for many of the largest tech companies and most popular startups that receive many applications each year. Now, as a hiring manager, you're on the other side of the hiring experience, shepherding a shrinking pool of candidates through the recruiting funnel until you make a hire. Sometimes, you will have the opportunity to work with a recruiter for some of these steps. As a general rule, the number of hiring managers at most organizations far exceeds the number of recruiters. So, having a recruiter supporting you is a luxury. Instead, you might need to carve out many of the activities up and down the recruiting funnel into your schedule so that you're leading them yourself. And even if a recruiter is available to help you, you are still responsible and accountable for making the hire. You can't delegate hiring responsibility to your recruiter because the recruiter may not have all the knowledge about engineering and your team's needs in order to make the right hiring decisions for you. Finally, an additional objective of the recruiting funnel is to find diverse candidates who are culture adds to the company and to your team. For example, Amazon, Google, and Microsoft all publish reports on the diversity of their workforce and hiring. Amazon states, "We actively recruit people from diverse backgrounds and foster an inclusive workplace." This graphic shows a typical engineering recruiting funnel adapted from Lightspeed's study of startups, along with the pass-through steps for each step of the funnel. Again, according to a Lightspeed study of engineering hiring at late-stage startups. At the start of the funnel, you, the hiring manager, write a job description that a recruiter working at a company reviews and posts to the public. Once your job description becomes public, you've told the world that you are hiring, and you give all interested candidates the ability to apply by responding to your job description. How do you write a job description? Well, often you can copy a previous job description used for a similar role, changing just some of the wording to better reflect your team or larger engineering organization. What are best practices for writing a job description that attracts the right candidates and attracts candidates of all backgrounds? For your next activity, let's find a job description that your organization recently posted. If there is none, or if you're not at an organization that posts job descriptions, find a job description for a role at an organization where you'd like to work. As we go through all the best practices for job descriptions, let's evaluate whether your job description meets our best practices or not. First, the job description should explain what impact the candidate will have. For example, is it AWS Backup's mission of protecting the data for millions of people and being the last line of defense for ransomware? Or could it be building smart devices to help the visually impaired accomplish previously difficult tasks? You can envision different engineers get very excited about one mission and maybe less excited about the other. As a hiring manager, your objective is to communicate the candidate's impact to attract those candidates who are most motivated to make that impact. For my organization, the impact of those I hire is tremendous. Each hire builds the culture on the team and inspires others to continue raising their bar of excellence. And for us, the mission is truly to help customers on AWS protect their data and secure their data. And it's with that mission that we're able to attract as well as retain and promote the engineers who are currently on the team. Second, the job description should explain what it's like to work on your team. For example, is it steady and working with mature products, or is it fast-paced and high growth with employees taking on a number of different responsibilities? Again, you can probably envision different engineers being more comfortable on one type of team than the other. Being transparent about what you expect of your team members up front helps you find candidates who would feel more at home on your team. I like to describe my organization's environment as very meritocratic and pretty flat. Oftentimes, I, as well as managers on my team, encourage some of the more junior engineers or fresh college graduates to voice their opinions and their proposals in larger group meetings. And this way, it really builds upon that culture and environment that if you have a good idea, all you need to do is simply voice it, bring the data, and provide that convincing argument. Third, the job description should explain what personal success in this role looks like. For example, is success having extremely deep knowledge of one particular system, or is it being able to touch a wide variety of systems and technologies? These are two common preferences that engineers exhibit, and there are many more that will help you source the right candidate. I like to describe personal success in my organization as a sum of several top Amazon leadership principles. One is being able to hire and develop the best. So whether you're an engineering manager or a senior individual contributor, your ability to encourage other top talent to join the team, to grow talent that's already on the team, is super important and one measure of how I see personal success. The other measure would be deliver results. Are you able to execute on highly ambiguous projects and still be able to complete them on time while delighting the customers with their functionalities and, again, being very secure in how you deliver that product? And finally, in ownership. So we talked a lot about accountability and responsibility. And it's truly, no matter who you're delegating that particular task or responsibility to, are you accountable? And do you demonstrate accountability for the overall product or project, in that if the project or the team were to run into any roadblocks, are you there to help them solve their problems? Are you there to help them unblock? And that's truly what I look for in a real owner. Fourth, the job description should contain a combination of different writing styles, such as narrative and also bulleted text. Doing so might attract candidates with diverse thinking styles. And fifth, ask, does the job description contain as few required credentials as are absolutely essential? According to an often cited Hewlett-Packard study, men apply for a job when they meet only 60% of the qualifications, but women apply only if they meet 100% of them, because of a, quote, confidence gap between men and women. You can bridge this confidence gap by reducing the required credentials to only those that are truly required. For example, if you're looking for an experienced engineer, is it really mandatory that they must have worked in distributed systems and on data security, data protection, backup recovery products? Or are you simply looking for an intelligent engineer who has familiarity with the software programming languages that you use for your product and who may have, let's say, 2 to 3 years of industry experience? If so, state that. Remove unnecessary skills that are not mandatory for success. Finally, is the wording gendered, or does it suggest that the role has an in-group? Obvious examples of gendered words are he and repairman. Recent research indicates masculine words such as leader, competitive, or dominant also make women apply less frequently because they feel like they wouldn't belong in the role. Now, these nuances in language can be tricky to detect. So it might also help to ask people who are from other diverse backgrounds, such as your team members, recruiters, and your friends, to read your job description. Then ask them to tell you who they think would belong in that role. If they perceive more women or more men or another specific group of people filling the role, as opposed to the role being open for people of all backgrounds, make sure to ask them why. A programmatic way to detect gendered language is the gender decoder, where you can copy-paste your job ad into the text box and let it spot potentially gendered words for you. Remember that in-groups extend beyond gender. For example, if you make nautical references in your job ad, you may be selecting for certain in-groups that have had access to sailing activities. If this is a bona fide occupational qualification, meaning that maybe you're requiring engineers you hire to know those nautical terms because they'll build boats or software for boats, then that would be an acceptable requirement. But outside of that narrow circumstance, it's best to write your job description using language that all groups of people can relate to. And once your recruiter publishes your job description so that the public can see it and apply to your job, you should share it through your social media and other networks. According to the job website, Glassdoor.com, 79% of job seekers use social media in their job search. Using your own social media is worthwhile. This is also a great way to receive referrals from colleagues or friends who know people who would be a good fit for your role. You'll also start to begin to receive resumes from applicants. You can sort through these resumes. If you're working with a recruiter, they might sort through maybe 25 resumes and send you 5 that they think most closely resemble the candidate that you would like. When recruiters present you resumes, they expect you to give them feedback in the sense of, yes, I want more like this, or these are not the best candidates because of one reason or another. Common reasons to help guide the recruiter's decisions are that perhaps, in many cases, you actually want a more diverse candidate. And so in these cases, you provide them a list of qualifications, maybe years in industry, types of industry that they've worked in, and the diverse qualifications that you would like. Other times, for example, include instances where you want to staff a specific role with someone perhaps who has multiple years with experience in that job family. So for example, you may not want a brand new engineering manager. You may want someone who has had at least 2, 3, maybe even more years of experience building distributed software systems. And so those are the qualifications that it's really helpful to share with your recruiter so that when they're helping you to source candidates, they know what you want and they have that in mind when talking to interested job candidates. And finally, although you'll accumulate resumes, experienced software engineers can be so sought after that they sometimes don't even apply for roles. For example, they simply maintain a LinkedIn profile and wait to be contacted. You can contact these engineers, usually with the message, quote, "Are you interested in this role? And if not, do you know someone who is?" Doing so is worthwhile because it introduces you and the opportunities you have to that engineer, even if they're happy with where they are right now. In the next step of the recruiting funnel from Lightspeed Survey, the recruiter emails candidates with promising resumes and social media profiles to schedule time to talk. According to Lightspeed, 19% of candidates emailed will make it to the recruiter phone screen. So that means, in real terms, out of a pool of 100 people that the recruiter emails, only 19 make it to this first step. So during this phone screen, the recruiter attempts to establish basic information about the candidate, such as their level of familiarity with your company and the products that it builds, knowledge, skills, and experience related to that position. Availability to change jobs, for example, if they are available now, or they might need to wait several months for a contract or a big project to wrap up. Their level of interest in the role, for example, whether working at your company is a childhood dream for them, or if they're simply looking for a change. And finally, logistical information, such as where they're located, which office they may work out of, and whether they're open to relocation or if they want a fully remote job where they can work 100% of the time from home. According to Lightspeed, 56% of candidates in the recruiter phone screen make it to the manager phone interview. Out of the original pool of 100 people at the start of the funnel, 11 people make it to this step. You conduct the manager phone interview, which involves structured, technical, and behavioral interviewing. Structured interviewing is a technique to standardize hiring and reduce bias across your organization. In structured interviewing, you might choose questions from an approved question list or question bank to ask a candidate. For examples of publicly available questions originally asked by Amazon, Google, and Meta, formerly Facebook, check out Advancing Women in Tech's Real-World Product Management Specialization, also available here on Coursera. It contains a number of behavioral, algorithm, and data structure questions that top tech companies ask of both their product managers and engineers. The opposite of structured interviewing is unstructured interviewing. During an unstructured interview, you and the candidate can talk about whatever you want. Unstructured interviews are not best practice because they can be a less likely or a worse predictor of performance. Two purposes of the manager phone interview are to personally interact with a candidate and also determine whether that you should bring the candidate on site. The term on site refers to flying the candidate out for a day of back-to-back interviews, often accompanied with lunch with a potential teammate on the new team that you would be joining. Of course, during COVID, on-sites have become fully virtual. Now they're also called interview loops. If you have limited recruiter support, you might have to combine all questions and content in both the previous step, the recruiter phone screen, and this step, the manager phone interview, into a single call. So if that's the case, pace yourself so that you can both fully assess the candidate as well as answer the candidate's questions. According to Lightspeed, 42% of candidates make it to the on-site, which means out of the original pool of 100 people at the start of the funnel, only 5 make it to this final step. The hiring manager is responsible for setting up the loop. A loop usually consists of around 5 interviews with 5 interviewers, each of whom might ask certain questions from a list of questions. Before the loop, your responsibilities include staffing the loop with interviewers, briefing the interviewers on what to focus on, and sometimes serving as an interviewer on the loop itself. Each interviewer on a loop spends about an hour of their time interviewing a candidate. The interviews are often structured interviews, meaning that the interviewers follow the same structure to give every candidate a level playing field and prevent subconscious bias. As a hiring manager responsible for the loop, a best practice is to maintain many relationships throughout your organization so you aren't just using the same members of your team for every loop. After the loop, you will participate in a meeting with the other interviewers and discuss whether or not, as a collective, you are to extend a candidate an offer. As you can tell, loops are quite time intensive. Only call them for very strong candidates to hire. According to Lightspeed, 31% of candidates make it after the onsite to receiving an offer, which means out of the original pool of 100 people emailed, Only 2 make it to this step. Usually, your recruiter delivers the offer and handles any subsequent negotiation while keeping you informed. Your recruiter has delivered so many offers, so you should leverage their experience in explaining how your company's compensation structure works and addressing any special requests a candidate might have, such as pre-existing vacations that they have already planned or family obligations that they need to meet. If your recruiter needs guidance or action from you, they will let you know. And finally, according to Lightspeed, 65% of candidates actually accept the offer, which means out of the pool of 100 people originally emailed, only 1 actually make it to this step. So at this point, you might be thinking 2 things. First, there's a finite number of software engineers in your area. If you keep emailing 100 of them just to hire 1, would you end up asking the same people to join your team over and over again? Second, all the steps in the hiring funnel seem like a lot of work just to get 1 hire. Are there ways to improve my odds? The answer to both is to create candidate pipelines. A candidate pipeline is a pool of qualified people that regenerates or replenishes itself over time, so you're not recruiting from a stagnant and shrinking pool of available candidates. Furthermore, the candidates in your pipelines should be familiar with who you are and ideally be more enthusiastic about the opportunity to work with you than someone who spoke with you for only 30 minutes over the phone. One obvious candidate pipeline for junior engineers is any university computer science program. The program produces a new cohort of graduates every single year. To access this candidate pipeline, you could do a number of things. For example, you could teach as an adjunct professor, so your students are already familiar with working with you. Then hire your best students. 2, befriend faculty and ask them to refer their best students. That way, the students will trust your professor's judgment and be interested in working with you. Or 3, partner with a computer science program to offer internships to their students so that they can work with you over the summer and decide to continue working with you and your team and your company when they graduate. Another effective candidate pipeline are nonprofits and associations like Advancing Women in Technology. As companies like Google Fitbit, like Amazon Web Services, AWS Startups, and MongoDB sponsor AWIT events, they send their recruiters to attend, meet, and hire AWIT members, many of them who come from diverse backgrounds. So what is a candidate pipeline you have access to? And how will you increase your visibility to that candidate pipeline that candidates will want to contact you and work with you? Please share your ideas in our discussion. Now that you've thought about your own candidate pipeline, let's look at Lightspeed's recommendations for balanced hiring channels. Lightspeed advocates that startups follow the rule of happy thirds for hiring. The rule of thirds states that 1/3 of your hires should come from each of these 3 categories. 1, source candidates. 2, applied candidates. And 3, employee referrals. An employee referral is a candidate known to you or other employees at your company who are introduced to you for a position on your team. To increase the number of employee referrals, you might consider reminding your team members that work is more fun with friends and telling them about your organization's employee referral program. By contrast, a source candidate is a candidate who you and the other employees at your company do not have a pre-existing relationship with, but who you actively identify as a good fit for the role. Maybe you identify them through LinkedIn, by reading their blog, or by meeting them at an industry event. You can approach the candidate, invite them out for coffee, and get them interested in joining your team. To increase your number of source candidates, you might consider getting into a habit of spending regular time on LinkedIn or at industry networking events. Lightspeed recommends that, in addition to you performing sourcing, you should teach everyone in your company how to source. An applied candidate is one who reaches out to you, often by applying to your job opening. So if you're a manager at a startup, to increase the number of applied candidates, you might consider investing in your company's brand to attract more applied candidates. Lesson 3, nurturing the candidate's trust and commitment. So far, We've spoken about recruiting in very conceptual terms, in terms of funnels, pipelines, and scripted questions. What do you do during the extremely limited time you actually spend unscripted with each candidate? How do you conduct yourself? How do you decide whether to proceed with the candidate to the next stage? We answer these questions in this lesson on nurturing the candidate's trust and commitment. What do you do when you start talking to a candidate? Regardless of whether this is your first phone call or your final interview with a candidate, spend your time on the following tasks. 1. Learning about the candidate as a unique individual with unique motivations. 2. Being honest about the candidate, about what they can expect from your team. 3. Following up with a candidate regularly. And 4. Envisioning how well the candidate would perform on your team before deciding on next steps. The first task is to learn about the candidate as a unique individual. Why is this important? You might love certain things about your work. You might love that there's a great daycare in the building and that you can bring your dogs to work with you. But talking about these perks won't appeal to a candidate who has no children and is afraid of dogs. That candidate would probably be more interested in other perks, like being able to sit in a dog-free zone. So limit how much time you spend explaining what you do, what you require, and why you personally enjoy your work, and spend more time redirecting the conversation to the candidate's own professional goals, questions, and concerns. As one example, when one of my colleagues first started interviewing, we were expected to go to an office in person. I was interviewing someone who lived in the state of Rhode Island, which I knew was within commuting distance of our Boston offices. I initially decided we could not hire the candidate if he wouldn't commute or consider relocating. However, during the interview, I decided to ask him how often he commuted to Boston. He said he had great difficulty doing so because he was physically disabled. This new information opened up other opportunities to accommodate this candidate based on his disability. And another story where I actually also hired a product designer to my team, and this is another instance about a few years ago. I had learned that due to the pandemic and due to a need to be closer to family out on the East Coast, this candidate had already relocated across the country from Seattle to the state of Virginia. We realized that this individual had really great skills to join our product team, but that this person would not be able to be relocated or to be co-located with the rest of the team here in Seattle. So in that instance, we asked the candidate if they would consider, for example, working West Coast hours, even though they were based on the East Coast. Now, of course, in this situation, everything worked out well because expectations were clear and expectations were made upfront so that both sides knew what the other side was getting into before they entered into this contract. And I'm happy to say that now, more than 2 years later, the working relationship is great. The expectation remains the same, that the individual work West Coast hours while on the East Coast and make regularly trips to the West Coast offices in Seattle, Bay Area, and Vancouver to visit with the team. So make sure that you understand the personal situation of the candidate that you're talking to and making sure that you can tailor the recruiting experience to that individual. Hey, you might be surprised. It will probably yield better results than you could have imagined. The second task is to be honest to the candidate. Often, you can infer what the candidate wants to hear, or the candidate will simply tell you what they want and ask you to agree to their request. However, if what the candidate wants is not something you can absolutely give to the candidate, then it's always better to be honest than to tell the candidate what they want to hear. Common examples are if the candidate tells you that within 1 year of their hire date, they want to be the tech lead for a big launch, or get promoted to a certain level, or make a minimum amount of compensation. While you might be able to accommodate the candidate's requests at the time of hire, you cannot guarantee that the candidate will be doing a year after the hire. You shouldn't be guaranteeing a specific project or role that they'll be working on because things might change between now and then. You can't guarantee their promotion to another level or how much they'd make a year from now. What you can tell them are past projects that your team has launched and some general information about how you choose which projects to work on and which engineers you choose to lead and staff those projects. You can also talk, in general terms, about leveling guidelines and how the candidate can determine when they're working at one level versus the other, just like I covered in the previous module. And finally, you can explain that it would be dishonest of you to make any promises about future compensation. However, you and your company invest in top performers. To zoom out for a moment from these examples to every interaction you have as a manager with both candidates and existing members of your team, honesty is the best policy. This is true because you have a high degree of power over your team members' careers, and they will view any perceived dishonesty as a lack of trust or, for example, a cause of concern when joining your team. For example, I've had many cases where candidates would come to me saying, well, I want to join your team because it presents a way for me to get promoted. I want to get promoted in 3 quarters from now, and I see this big, exciting project on your team as a way for me to get there. Now, will you promote me in 3 quarters when, for example, I complete this successfully? Now, as a hiring manager, and especially if that candidate is just what you're looking for, with the right skills, the right experience, and you feel like is a culture add to your team, it can be very tempting to say, yes, right, we will promote you in 3 quarters if you're successful. But that's where I would caution you to pause, because you don't know what's going to happen. Maybe they look great on paper and they do have all the great experiences that you need and the right skills, but somehow are unable to fit well with the team. Maybe they don't take coaching well from higher leadership and are unable to complete the project. Given that you don't have any mileage under your belt or any data points, it can be very hard to say whether or not someone can be promoted in 3 quarters. So that's why, as a rule of thumb, I generally say really stay away from promising any specific dates or promotion quarters, especially before you've even worked with the candidate, even the best internal transfers. The third task is to follow up with promising candidates on a regular cadence, such as weekly. Sometimes it might take some time for your internal processes to happen, such as your next available loop. During that time, don't let promising candidates go for a period of time feeling like you've ghosted them. Instead, send them quick messages about recent launches or other publicly available news about your team or company, or just short emails to ask them how they're doing and to let them know what to expect in the future. Let promising candidates know that they're on the top of your mind, and they will begin to trust you as a manager before they even join your team. Make sure to schedule this as a weekly activity so that you don't forget. The final task is to envision how the candidate would perform on your team. Doing so informs your next step, whether to thank the candidate for their time or invite the candidate to the next step of the recruiting funnel. Remember that making a bad hire can severely diminish your team's performance and even cause existing team members to leave. So, does your limited time with a candidate give you enough information to make a good decision? Fortunately, it does. Journalist Malcolm Gladwell wrote in his book, Blink, The Power of Thinking Without Thinking, about the psychological concept of thin slicing, applying limited information from a very narrow period of experience to come to a conclusion. For example, doctors can accurately assess what illness a patient has after just a few minutes of examination. Marriage counselors can predict whether a couple will divorce in the next 15 years after just 3 minutes of observation. And even non-professionals, like students, can assess how good a professor is by watching just a few seconds of the professor lecturing on video. Thin slicing works by assessing your brain's subconscious, where it stores the sum total of all of your professional experiences. However, when you perform thin slicing, look out for unconscious biases. You're envisioning the candidate's future performance on your team, not how similar the candidate is to you. Likewise, economist and Nobel Prize winner Daniel Kahneman wrote in his book, Thinking Fast and Slow, about his experience creating tests for the Israeli Defense Forces to assess recruits' combat readiness. After administering a structured interview to each recruit, Kahneman instructed the interviewers to try to imagine the recruit as a soldier and assign him a score of 1 to 5. Kahneman weighted the close your eyes score just as much as the structured interview ratings because it was just as accurate a predictor of combat readiness. Large tech companies have adopted these interviewing approaches for interviewing their candidates. One example of a tech company adopting structured interviewing can be found in Eric Schmidt's and Jonathan Rosenberg's book, How Google Works. The approach for interviewing engineers is similar across big tech companies. Administer structured interviews, reflect on the candidate's performance, and record your observations before you make a decision on a candidate. Likewise, you already know what your team needs, and from your own professional experiences, what makes a great team member. Based on the sum of your professional experiences, along with your brief, structured interactions with each candidate, the research indicates that you already have sufficient information to predict with high accuracy how the candidate you interviewed will perform. So close your eyes. Imagine how well your candidate will contribute to the team and use that to decide on next steps. Congratulations! You've reached the end of our module on hiring your team. If you're interested in putting your hiring knowledge to practice, consider any of these following next steps. Finding and taking the training that your company offers for interviewing candidates. Asking to shadow interviews with more experienced interviewers. And practicing recruiting and referring others to your own team. But for now, come join our next topic on setting goals or how to give your team purpose. Coursera 3, Engineering Management, Course 1, Module 3. Setting your team's goals. Starting with Lesson 1, Proposing Goals for Approval. Hello and welcome to our module on setting your team's goals and giving your team members purpose. By the end of this module, you will learn how to propose goals for your team, how to draft 2 common types of goals, the Amazon-style SMART goals, and the Google-style Objective and Key Results, abbreviated OKRs, and how to communicate your team's progress towards those goals. As I mentioned during the start of this specialization, engineering managers are responsible and accountable for 2 very basic goals. 1, grow your engineering team, and 2, deliver on your commitments. In the previous module, we covered how you, the engineering manager, hire your team. Now let's assume that you've already hired your very own 2-pizza team of 7 engineers. Now, we'll cover how to set your commitments and track your progress on how close you are to delivering on your commitment. Let's start with, what are commitments? Commitments are goals that you propose and that your leadership approve. Once a goal you propose becomes a commitment, you are responsible and accountable for meeting or exceeding that commitment. You develop your professional reputation based on the difficulty of commitments you take and your track record on whether you meet them. Your leadership will review your proposed goals during periods called planning cycles. Planning cycles occur regularly, for example, once every year. So, every year, during your planning cycle, you must propose a new set of goals to explain what your team will do for the next year. Your goals help define the strategy for your team. A strategy is a set of long-term objectives for your team, which might take a year or longer to achieve. The opposite of strategy is tactics, or the short-term actions you lead your team to do every month, week, or day. An example of a tactic is agile software development. We'll cover tactics like that in the next module. Having commitments is very important for 3 reasons. First, your commitments tell the members of your team what they can look forward to during the long term so that they can prepare themselves. Second, your commitments inform your leadership and other teams of your long-term plans. Your leaders can incorporate your team's plans into the entire business goals, whereas managers of other teams can propose cross-functional goals, connecting their goals with your goals because both teams working together can deliver more than the 2 teams working in isolation. Third, And just as importantly, it tells everyone from your team members to other teams what your team will not do during the long term. This decreases the probability that leadership or other teams can randomize your team with unplanned tasks. Now, let's talk about 4 ways to categorize goals: top-down goals, bottom-up goals, cross-functional goals, and team goals. The first type of goal is a top-down goal. A top-down goal comes from your leadership and requires you and your team to accomplish it. You encounter top-down goals frequently throughout your life. An example might be you must maintain a grade point average of 3.0 or above in order to remain in the program. This goal applies to you and to everyone else in your program, no matter what their particular interests or which courses they elect to take. A top-down goal at a software engineering organization might be everyone in the organization must complete our annual security training. As a manager, you are responsible and accountable for all of your team members finding the time and the effort that's needed to complete this training. If just one member of your team does not complete the training, your organization's leadership might come to you and ask why. The second type of goal is an individual or bottom-up goal. Individual goals reflect your personal interests and desires, but might have minimal impact on others around you. You set individual goals for yourself all the time. An example might be, I want to complete this Coursera specialization by the end of this month. A bottom-up goal at a software engineering organization might be one of your team members asking you if they can build a feature. As a manager, you should compliment your engineer for their initiative, but also evaluate whether the time and effort spent on this bottom-up goal might negatively impact the rest of the team before saying yes. A combination of dev goals and ops goals is evidence that your team practices DevOps, meaning that each engineer on your team spends time on development and some time on operations. To be clear, to follow the DevOps model, you don't assign the same 3 engineers to go on call and resolve emergent issues all the time. Rather, to practice DevOps correctly, you rotate every member of your team, including yourself, the manager, to all take turns going on call. On call can be difficult. It potentially involves getting a page about an emergent issue at any time, including at 3 a.m. in the morning. So why would you subject yourself and your team members to that experience? Because many decades ago, and some companies still do this now, most software companies split their development and operations into 2 different organizations. For example, an American software company might perform all of their development in the United States, but outsource operations to engineers in a lower cost country. So an engineer working at that company would only practice development or operations, but not both. The engineers performing development could only hear about customer issues and fixes secondhand, and the engineers performing operations could not apply their knowledge of customer issues to build new features. Then some companies tried rotating the same engineers between dev and ops, inventing DevOps. How much does DevOps improve the performance of your team? According to a DevOps trade group and also Google, the software engineering managers who reject the separation of dev and ops and who practice DevOps make code deployments 200 times faster, recover from incidents 2,600 times faster, and experience 7 times lower failure rates than those who don't. So in general, committing to operations goals and making everyone in your team responsible for core operations and emergent issues is the engineering best practice. The drawback to taking this goal is that your team and you have to go on call rotations and occasionally receive pages outside of business hours. However, the benefits of doing so are substantial, including to your team members' development of software engineering skills, that many engineering managers decide that following the DevOps model is worthwhile. Now that we understand what this short list of goals mean, let's go back to our hypothetical. These are your goals, and you've presented them for approval to your leadership. Do you think your leadership would approve these goals? Probably not. Why not? Because it's not clear why you're doing any of these things, with the exception of core operations, which is required to continue your business. The 4 fundamental reasons why you should pursue a goal and the metrics you should always track as a software engineering manager are to increase revenue, to decrease costs, to gain or keep customers, and 4, to comply with laws and top-down goals. So let's say your leadership sends you back to justify your goals. After working with your product managers, finance team, and other colleagues across your organization, you go back to your leaders with the following justifications. You predict Goal 2 to generate $2 million at the cost of 4 engineers. You predict Goal 3 to generate $5 million at the cost of 5 engineers, and you predict Goal 4 to save only $500,000 at the cost of 2 engineers. However, it is also a requirement of your organization. This gives your leadership enough information to evaluate your proposed goals. Let's assume they agree with your engineer estimates and give you the following feedback. All other considerations being equal, Feature B seems to present a better investment than Feature A per head of investment. Furthermore, although refactoring the existing systems gives the least return on investment, leadership approves of it because they required it as a top-down goal. This means your proposed goals are approved with the following language. The goal to launch Feature A is moved below all of the approved goals and below the cut line. You are responsible and accountable for delivering all the goals above the cut line. You are not responsible or accountable for delivering goals below the cut line. Why not? Because leadership did not approve the 4 engineers necessary to launch Feature A. Why do we even have a cut line? Why not just delete the unapproved goal? There are several reasons, all having to do with this being the list of goals for you to deliver next year. First, if next year you're successful and deliver all 3 goals for that year ahead of schedule. Well, first off, kudos and congratulations. You have engineers available, and rather than having no goal, you can staff them on launching Feature A. Second, if you don't deliver all 3 goals ahead of schedule, launching Feature A is likely to become one of the goals you ask for during the next planning cycle. Third, between now and the end of next year, there might be a major shift in your customers' needs, and they might suddenly need you to launch Feature A immediately. Then you can use that as an input to reprioritize your goals. For example, with your leadership's approval, you can move your goal to launching Feature A above the cut line and make room for it by moving your goal to launch Feature B below the cut line. To summarize, at this stage in the planning cycle, you have determined that next year, you have taken the commitment of delivering the following 3 goals: core operations, launching Feature B, and refactoring your existing systems. To accomplish these tasks, your leadership has approved you to hire a team of 10 engineers. Since your current team only has 7 engineers, you should start hiring 3 engineers and have them in place before next year begins. If you do not perform this hiring in a timely fashion, you risk jeopardizing your goals by not having enough engineers on your team to deliver. Congratulations! You've completed a planning cycle and received approval for your goals for next year. You now have a set of commitments to deliver. Your next step is to share your goals with your team and assign their individual goals. The work you'll delegate to each of them to complete the overall goals. For each goal, you might even assign one of your engineers as the goal owner, meaning that they have the responsibility to lead the goal to completion and report on its progress. This is an example of delegation. As we explained in our previous content, as a manager, you are expected to delegate responsibility for meeting goals, but you cannot delegate accountability for whether or not you meet your commitments. At this point, let's review our first goal, which is, in full, core operations. How do you know if you met your team goal of core operations at the end of next year? In our next lesson, we look at how to break down large strategic goals like core operations into smaller, measurable goals that everyone can understand and work towards. A combination of dev goals and ops goals is evidence that your team practices DevOps, meaning that each engineer on your team spends time on development and some time on operations. To be clear, to follow the DevOps model, you don't assign the same 3 engineers to go on call and resolve emergent issues all the time. Rather, to practice DevOps correctly, you rotate every member of your team, including yourself, the manager, to all take turns going on call. On call can be difficult. It potentially involves getting a page about an emergent issue at any time, including at 3 a.m. in the morning. So why would you subject yourself and your team members to that experience? Because many decades ago, and some companies still do this now, Most software companies split their development and operations into two different organizations. For example, an American software company might perform all of their development in the United States, but outsource operations to engineers in a lower-cost country. So an engineer working at that company would only practice development or operations, but not both. The engineers performing development could only hear about customer issues and fixes secondhand, and the engineers performing operations could not apply their knowledge of customer issues to build new features. Then some companies tried rotating the same engineers between dev and ops, inventing DevOps. How much does DevOps improve the performance of your team? According to a DevOps trade group and also Google, the software engineering managers who reject the separation of dev and ops and who practice DevOps make code deployments 200 times faster, recover from incidents 2,600 times faster, and experience 7 times lower failure rates than those who don't. So in general, committing to operations goals and making everyone in your team responsible for core operations and emergent issues is the engineering best practice. The drawback to taking this goal is that your team and you have to go on call rotations and occasionally receive pages outside of business hours. However, the benefits of doing so are substantial, including to your team members' development of software engineering skills, that many engineering managers decide that following the DevOps model is worthwhile. Now that we understand what this short list of goals mean, let's go back to our hypothetical. These are your goals, and you've presented them for approval to your leadership. Do you think your leadership would approve these goals? Probably not. Why not? Because it's not clear why you're doing any of these things, with the exception of core operations, which is required to continue your business. The 4 fundamental reasons why you should pursue a goal and the metrics you should always track as a software engineering manager are to increase revenue, to decrease costs, to gain or keep customers, and 4, to comply with laws and top-down goals. So let's say your leadership sends you back to justify your goals. After working with your product managers, finance team, and other colleagues across your organization, you go back to your leaders with the following justifications. You predict Goal 2 to generate $2 million at the cost of 4 engineers. You predict Goal 3 to generate $5 million at the cost of 5 engineers. And you predict Goal 4 to save only $500,000 at the cost of 2 engineers. However, it is also a requirement of your organization. This gives your leadership enough information to evaluate your proposed goals. Let's assume they agree with your engineer estimates and give you the following feedback. All other considerations being equal, Feature B seems to present a better investment than Feature A per head of investment. Furthermore, although refactoring the existing systems gives the least return on investment, leadership approves of it because they required it as a top-down goal. This means your proposed goals are approved with the following language. The goal to launch Feature A is moved below all of the approved goals and below the cut line. You are responsible and accountable for delivering all the goals above the cut line. You are not responsible or accountable for delivering goals below the cut line. Why not? Because leadership did not approve the 4 engineers necessary to launch Feature A. Why do we even have a cut line? Why not just delete the unapproved goal? There are several reasons, all having to do with this being the list of goals for you to deliver next year. First, if next year you're successful and deliver all 3 goals for that year ahead of schedule. Well, first off, kudos and congratulations. You have engineers available, and rather than having no goal, you can staff them on launching Feature A. Second, if you don't deliver all 3 goals ahead of schedule, launching Feature A is likely to become one of the goals you ask for during the next planning cycle. Third, between now and the end of next year, there might be a major shift in your customers' needs, and they might suddenly need you to launch Feature A immediately. Then you can use that as an input to reprioritize your goals. For example, with your leadership's approval, you can move your goal to launching Feature A above the cut line and make room for it by moving your goal to launch Feature B below the cut line. To summarize, at this stage in the planning cycle, you have determined that next year, you have taken the commitment of delivering the following 3 goals: core operations, launching Feature B, and refactoring your existing systems. To accomplish these tasks, your leadership has approved you to hire a team of 10 engineers. Since your current team only has 7 engineers, you should start hiring 3 engineers and have them in place before next year begins. If you do not perform this hiring in a timely fashion, you risk jeopardizing your goals by not having enough engineers on your team to deliver. Congratulations! You've completed a planning cycle and received approval for your goals for next year. You now have a set of commitments to deliver. Your next step is to share your goals with your team and assign their individual goals. The work you'll delegate to each of them to complete the overall goals. For each goal, you might even assign one of your engineers as the goal owner, meaning that they have the responsibility to lead the goal to completion and report on its progress. This is an example of delegation. As we explained in our previous content, as a manager, you are expected to delegate responsibility for meeting goals, but you cannot delegate accountability for whether or not you meet your commitments. At this point, let's review our first goal, which is, in full, core operations. How do you know if you met your team goal of core operations at the end of next year? In our next lesson, we look at how to break down large strategic goals like core operations into smaller, measurable goals that everyone can understand and work towards. Lesson 2, Making OKRs Smart. In this lesson, we're going to use 2 goal-setting methodologies to edit, refine, and clarify our goals. These methodologies are Google-style objectives and key results, abbreviated OKRs, and Amazon-style SMART goals. We're going to combine these methodologies to bring clarity to big, complex goals like core operations and launch Feature B. OKRs were invented in the 1970s by Intel CEO Andy Grove. In 2017, Google co-founder Larry Page, the man who temporarily abolished all managers from Google, wrote, quote, "OKRs have helped lead us to 10x growth many times over. They've kept me and the rest of the company on time and on track when it mattered the most." Here is an example of a real OKR from the email startup Superhuman, which achieved a $260 million valuation in 2019. The objective is their larger goal. In this example, the objective is to refine the entire Superhuman experience to remarkable quality. Every objective should have 3 to 5 key results. The key results are time-bound and measurable milestones that express whether or not you have met that goal. For example, the first key result is grow to X annual recurring revenue by the end of the quarter from the current revenue of Y dollars. The second and third key results involve improving sentiment. It's not clear how Superhuman measures sentiment, which might refer to customer sentiment. For this key result to be useful, there must be an internal metric Superhuman's managers have agreed to for what sentiment means and how to calculate it. To avoid this ambiguity, when you write your OKRs, you should include definitions and formulas so that everyone involved in the goal approval process know that they're reviewing and approving the same goal. Remember that key results should be both measurable and time-bound. It's not clear what the time boundaries are for Superhuman's key results. Maybe the time frame is implied as by the end of the year or the end of next year, depending on Superhuman's planning cycle. To avoid this ambiguity, when you write your OKRs, you should have an explicit end date to achieve each key result. At Google, teams set OKRs both quarterly and annually, and these goals are visible throughout the company, going all the way up to Google-wide OKRs. At the end of each quarter, managers assess their progress to the key results and score their progress to accomplishing their objective from 0, meaning no progress, to 1, meaning 100% completion. Google's guidance is that the average team should score their progress at around 50% to 65% to encourage teams to take on challenging moonshot goals. Applied to the Superhuman example, if the revenue grows halfway between Y dollars and X dollars, that would still be considered an acceptable performance. On the other hand, if a team is scoring their progress as 100% all the time, the manager might be engaging in sandbagging. Sandbagging is the act of deliberately setting goals for yourself and your team so unreasonably low that you can easily outperform your goals. At Google, those who keep scoring 100% on their OKRs are encouraged to set more challenging goals for their teams. Ready to draft our own OKRs? Let's clarify the first goal, core operations, by turning into an objective with 2 example key results. Remember that Google-style OKRs have between 3 and 5 key results, but our example will only have 2. Following Superhuman's example, we can reframe the objective core operations into something more aspirational, such as maintain operational excellence. Next, we can think about inputs for operational excellence in software engineering. Let's pick 3 key objectives: availability, failures, and high severity tickets. Availability is how much of the time your software is available for customers to use. This is often expressed as a series of nines. For example, 99.9% availability, or 3 nines, means that your software is down or unavailable for no more than 3.6 days per year. 99.99% availability, or 4 nines, means that your software is unavailable for no more than 53 minutes per year. 99.999% availability, or 5 nines, means your software is unavailable for no more than 5 minutes per year. And you can have additional nines for increasingly stringent availability requirements. Let's assume that we're currently at 4 nines of availability, but we want to take a goal to improve it to 5 nines. So we might write the availability key result as achieve 5 nines of availability during fill in the year, an improvement from 4 nines of availability last year. What does this goal communicate to your team? It tells them to value efforts that improve reliability. For example, they can build redundancies into your systems to remove single points of failure. They can also deploy tests and other detection methods to predict failures that would knock out the system. If those tests are triggered, your team can respond proactively to avoid downtime. Finally, they can even build mitigation mechanisms that automatically take effect, giving the team more time to respond. Now let's think about another key result of operational excellence: high severity tickets. Let's define what high severity tickets are. A ticket is a record of work that software engineers, like those on your team, need to perform. When your team's on-call engineers receive a ticket, they perform the work, then resolve the ticket. Many people can create or cut tickets for you. These people range from other engineers in your organization to your organization's support engineers to your customers themselves. Each ticket has a severity, abbreviated SEV. Tech company Atlassian, which makes the popular Jira software, explained that there are often 3 severity levels. A SEV1 is a critical incident with very high impact, such as customer data loss. A SEV2 is a major incident with significant impact, such as a core functionality of your software is not working. And SEV3 is a minor incident with low impact, such as a typo in your software's user interface. Atlassian's website states, at Atlassian, SEV3 incidents can be handled during daytime working hours, while SEV1 and SEV2 incidents generate an alert for on-call professionals for immediate fix no matter the time of day. As an engineering manager, people cutting your team tickets is part of the job. However, you want to minimize the need for others to cut you high severity tickets, those being the SEV1 and SEV2 tickets, because they indicate something is seriously wrong with your software and cause your team members on call to drop everything to fix it, distracting them from their other goals, which could include feature delivery and development. So, our second key result might read, reduce total high severity ticket, SEV1 and SEV2, ticket count during fill in the year to 150, a reduction from 200 last year. Now that we have our key results, we want to test them for the 3 characteristics of good goals, whether they're smart, whether they're bold, and whether they're countervailing. SMART goals were invented in 1981 by George Doran as a way for managers to write and review goals, and are still in use across the software industry. SMART is an acronym that stands for specific, measurable, achievable, but bold, relevant, and time-bound. Let's start from the first 2 requirements of a SMART goal. Are our key results specific and measurable? That is, are they clearly defined, and can we easily say, yes, you accomplished this goal, or no, you did not? Yes, our goals are specific and measurable. The first result calls for 5 nines of availability. We know that this means your software must be available throughout the year, except for up to 5 minutes of downtime. I can run reports on your downtime throughout the year and answer the question, did you achieve this goal with a clear yes or no? The second key result defines high severity tickets as SEV 1 and SEV 2 and also specifies a ticket count of 150. I can query our ticket system for the number of SEV 1 and SEV 2 tickets you actually received during the year. Here too, I can get a clear yes or no answer to, did you achieve this goal? Next, let's ask whether our goals are achievable and also bold. Notice that achievable and bold are two countervailing principles. When two things are countervailing, they push against each other, preventing your goals from being too achievable or too bold. Because your organization, in our examples, has an annual planning cycle. Goals are achievable when your leaders and team think you can reasonably achieve your goals during the next year. However, goals are bold means that you're challenging your team to perform at a higher level than they have previously performed. Setting bold goals prevents your team members from sandbagging you and helps them develop their engineering skills and careers. Ultimately, whether these goals are achievable are questions for the members of your team. Do they see the technical solutions that would allow them to increase availability and reduce ticket count by those numbers? What are those solutions? Do they have the time and expertise to implement them? Goals are bold when they challenge your team to perform at a higher level. It's hard to tell if the first goal is bold. If you're shooting for 5 minutes of downtime this year, was last year's downtime 1 hour or only 6 minutes? How much of the improvement comes from changes to your architecture and how much comes from chance? The second goal is also hard to judge without more context. Why were 200 tickets cut last year? Were 25%, 50%, or 75% of those tickets caused by issues you already fixed? Do you have to do anything else next year to reduce tickets? These are the sort of questions that SMART goals can help you ask and answer when you propose your own goals or when you're reviewing other managers' goals. Now, let's ask the easiest questions. Whether our goals are relevant and time-bound. Yes, both of our key results are relevant and time-bound. Goals are relevant when they closely align with your organization's mission and business. What's your organization's mission? Let's think about two different companies' missions. Google's mission is to organize the world's information and make it universally accessible and useful. Meanwhile, Microsoft's founding mission, which it only changed recently, was a microcomputer on every desk in every home running Microsoft software. So you can see how one goal, like a search engine, might be more relevant to Google than Microsoft. And other goals, like designing and manufacturing tablets, might be more relevant for Microsoft than Google. Relevance is also important for cross-functional goals. Remember what a cross-functional goal is? It's one that you take with other managers because you need their team's collaboration. For example, suppose you and another manager agree to take cross-functional goals. However, the other manager forgets to take their cross-functional goal and gets other unrelated goals approved. Now you've committed to a cross-functional goal without the support of the other team. In this situation, your goal is no longer relevant, and you have two options. Either you have to drop it for another goal, or the other manager needs to drop their other commitments to meet this cross-functional goal. In our example, there's no question that increased availability and reduced ticket count are relevant for operational excellence, because operational excellence means that we ship software that just works and doesn't break. Now that you know what it means for a goal to be relevant, let's focus on the last requirements for SMART goals, which is that they're time-bound. Goals are time-bound when they have a clear start and end. Here, our language that the work towards the goal takes place during a year we fill in time-bounds our goal. Only downtime on high-severity tickets we experience between the start and end of that calendar year count. Events that occur before that year or after that year do not count. Now that we've completed our review of whether our key objectives are SMART, I'll show you how different goals can countervail each other. I'm bringing up our second goal, to launch Feature B. And to make it a SMART goal, we've given it a delivery date, June 30th of the same year as your operational goals. Why does this development goal countervail your operational goals? Because to launch Feature B, you're making your software more complex, which might increase the possibility of downtime and potentially create more opportunities to receive SEV 1 and SEV 2 tickets. How do you control the potential impacts of those tickets? You control it using DevOps. With DevOps, you and your team of engineers take turns on call to help respond to downtime and to resolve tickets. By doing so, you and your team already know how to build feature B to minimize and even eliminate these risks. DevOps is how even small teams who mix development and operations goals countervail each other and cultivate faster releases of better software. Lesson 3, showing off your progress. Now, let's fast forward from the planning cycle to the next year. Let's assume that you've hired 3 more engineers according to your commitments. This year is your execution phase. It's time for you and your team to deliver all the projects above the cut line. How do you communicate your status to your leaders up to and including your company's CEO? And all of the other managers who have taken cross-functional goals off of your commitment. First, your company probably uses an internal goal tracking tool to give leaders and other managers visibility into your goals. Here's an example. You see the commitment, which is launch feature B by June 30th of this year. The next line is a goal owner, someone named Viola. Maybe Viola is the tech lead of this project. She's someone you've delegated as a goal owner. The line after that is the last update, which is May 11th. Then there's a status that Viola put. That status is green. The green status means that you, Viola, and all of the other engineers on your team have high confidence that you will meet your commitment of launching feature B by June 30th of this year. How do you define the words high confidence? You can define it as over 80% confidence, or that missing the commitment date would be very unexpected and reflect poorly on both you and your team. After a green status, the goal owner includes some information about what they accomplished last week and what they plan to accomplish this week. In this case, Viola's update is, last week we reached code complete. We cover what code complete means in another module. She also writes, next week we expect security approval and will start deployments. Let's fast forward into next week and see what happens. In this update, the status has changed from green to yellow. The yellow status means the launch date is in jeopardy, but there's still time for your team to recover and still deliver by the original launch date of June 30th. A yellow status requires 2 things, a reason and a path to green. In this example, the reason for yellow is that security refuses to grant approval due to overbroad permissions from the Badger team. This means that the Badger team, a different team under a different engineering manager, has permissions that your project needs as part of this launch, but that security won't let you use them because they're overbroad for your use case. The next example, security approval was expected on May 23rd, is very helpful because it marks the day when the project got off track. The final sentence of the reason, deployments are blocked, indicates why the launch date is in jeopardy. Without security approval, your team cannot deploy code. And without deploying code to the public, you cannot launch your feature. In this example, the path to green is Viola emailed the Badger team, which scheduled a meeting for May 26th. This suggests that you and your team believe that they can recover from this delay by speaking with the Badger team, and that they can fix their permissions issue in time for you to still launch on June 30th. Let's fast forward another week and see what happens. In this update, the status has changed from yellow to red. The red status means that there is no way you and your team can recover from the issue and still deliver by the original launch date of June 30th. The red status also requires a reason and a path to green. However, the path to green generally means here a revised later launch date. In this example, the reason for red is Badger team will not adjust their permissions, which will cause issues for other teams, and security refuses to grant us approval to use those permissions. Still cannot deploy. This means your team is caught between 2 other teams, neither of which is willing or able to accommodate the needs of the other. When you get stuck like this, often the path out is to escalate. We'll discuss escalation in a different module on how to deal with conflict. In this example, the path to green is escalated to head of engineering and principal engineer who are meeting with equivalents on both teams June 7th. A best practice that Viola is following up here is documenting the dates for the next action. Specific dates make it much easier for leaders to get up to speed quickly as they get escalated in to help. Let's fast forward 1 more week. In this update, the status changed from red to green. The update reads, permissions issue resolved by security granting us an exemption. Started deployments. This means the escalation was successful, and specifically, security dropped their objection to this launch after a consultation with your leaders. Notice also that your goal has changed due to the previous red status. The original June 30th launch date is crossed out and replaced by a new date of July 7th to account for the lost time. For particularly bumpy projects, there might be a series of 5 or more crossed out launch dates, followed by a final launch date, meaning that the project status kept bouncing between red and green at least 5 times. While not ideal, the more important thing you can do is to give your leaders and other managers with cross-functional goals transparency and visibility into your team's progress and blockers. There are 2 more project statuses that describe its final state that year. By December 31st, all of your projects should have the status completed or did not meet. The completed status means that you met your commitment. For example, you launched Feature B by July 7th, or you achieved 5 nines of availability throughout the year. The did not meet status means that you did not meet your commitment and that you will write your leadership an explanation on why you did not meet your commitment. Sometimes this can be deliberate. For example, if a change in market conditions causes customers to overwhelmingly want Feature A over Feature B, but you had committed to delivering Feature B during your planning cycle, it makes sense to deliberately not meet your commitment and pivot to delivering Feature A instead. That is an example of you exercising leadership and providing a strong justification for your decision. In other situations, this can be due to forces beyond your control, such as other teams not delivering your cross-functional goals or your team missing its own milestones. In either case, you as the engineering manager are responsible and accountable for all of the goals you commit to delivering. So your justification for why you did not meet your commitment should include a detailed explanation on how you will avoid similar issues in the future. Congratulations on completing our first of 3 courses in the Real-World Software Engineering Management Specialization. At this point, you've gotten a look at what some of the world's most effective software managers do. In the next course, we'll explore how engineering managers cultivate outstanding performers and also support team members who might be falling behind or have specific challenges. And in our third and final course, we'll take a look at how engineering managers work with their counterparts, the technical program manager. We'll also explore systems design problems that engineering managers like you are expected to solve. Finally, we'll talk about career progression from an engineering manager to a manager of managers, and from a manager of managers to a director of engineering, general manager, chief technology officer, or even the chief executive officer. I'll review the additional skills each of those roles require and how you can acquire those skills over time. If you'd like to support our upcoming content, please leave a quick and positive review for this course so that our partners Coursera and Amazon Web Services, AWS, can help us promote this and many of our other Advancing Women in Tech AWIT educational programs, such as Real-World Product Management Specialization and the Real-World Cloud Product Management Specialization, which takes students through a deeper dive in cloud services and technologies. Follow the URL in the next screen to leave a review. And did you know that you can earn college credit from completing Advancing Women in Tech educational programs on Coursera? As mentioned, these include the Real-World Product Management Specialization, which features more than 20 CEOs and other leaders and some of the world's most successful tech companies, and the Real-World Cloud Product Management Specialization, which also trains you to build applications on the cloud and become AWS certified. You can visit those specializations on the next screen.